Hi, my name is Jake Boston, and I am a sophomore in computer science at Mines, and I'm involved in ACM and ORSEC. I study computer science because I love learning about the details of how computers are able to accomplish all the tasks we depend on them for. I welcome you to the CSCI Python video. Today we're going to talk about the file system and how it's structured. Understanding the file system structure is key for reading and writing files, which will be the topic of the next video. But first, let's start with a good quote. Not all roots are buried in the ground. Some are at the top of a tree. This quote makes total sense once you understand how file systems are structured, which is the main topic of this CS at Mines Python video. But first, let's start with a review of our previous video on strings. Recall that putting a backslash in front of a character is called the escape character. An escape character allows us to tap into certain whitespace characters, such as tabs, and also allows us to turn special characters, such as quotes, into ordinary characters. For example, what will \this mistake print? This command will print a tab and then the words his mistake. Also recall that the % operator can perform two functions. First, it can take the modulus of two numbers, and second, it can be used for string interpolation, also known as variable substitution. Lastly, we can format strings using the .format function. In this function, we pass in variables that we want to substitute into the string of where sets of curly braces exist. Okay, let's now dive into the file system structure. To start, we're going to need to define some file terminology. All of these terms are used frequently in computer science, so they're good to know. The file system is the software on a computer that manages files. This software controls how files are stored, as well as how files are retrieved. In today's world, most people interact with the file system on a computer using a graphical user interface, such as Finder on Mac or File Explorer on Windows. Some people, however, interact with the file system through the command line via the Linux terminal. A directory, also called a folder, contains files. A file is an object that stores some type of data. For example, a text, document, image, program, or a directory. And yes, even a directory is considered a file to the file system. A path is the location of a file in the file system. We have two types of path, both of which are quite useful. The first is an absolute path. This means that we start at the root or top of our file system and then describe the full path to the desired file. The second is a relative path. We start at the current working directory in a relative path and then describe the path to the desired file from that directory. Check out the three relative path examples on this slide. Notice that the first relative path assumes that the current working directory is CSCI 102, and the third assumes that the current working directory is CSCI 101. This slide shows a very simple file structure with directories and files. Notice the tree structure, where the root is at the top. All the files and directories branch from this root. What is the relative path to the text file on the left if the current working directory is dir1? What about the absolute path to the text file on the right? We suggest you pause the video briefly and write down both of these examples. Now let's consider these two example paths together. For the relative path, because the current working directory is already dir1, the location of the text file is within dir1. Then the relative path is just txt1. That's it. An absolute path always starts at the root of the tree. So in this case, the full path is root/dir3/txt1. Here's a possible example file structure for a student in CSCI 102. This figure shows that the CSCI 102 directory has 3 directories inside of it. Then each weak directory has multiple Python files in it for the various labs the 102 student has worked on. We'll come back to this example file system structure in a minute. The next question to ask is, how do we open files in Python? We open files with the file object, which is a data type used to read and write files. A file object is created by using the open function, and this open function takes 2 parameters: the path to your file, which can be relative or absolute, and the mode, which specifies how to open the file. For example, open the file for reading. The purpose of this slide is to show an issue that often happens with file I/O. In this example, we have a line of code that opens a file for reading in part-a.py of the week 1 directory. This slide illustrates an example of a file not found error. In this case, Python is telling us that it cannot locate and open the file data.txt because, as shown, our current working directory, that is week 1, does not contain the file data.txt. Instead, that file is actually in the week 3 directory. We need to either move this file to the week 1 directory, or we need to provide a path, relative or absolute, to the file from the week 1 directory to the week 3 directory. The previous example shows opening a file for reading. We actually have several different modes that can be used to open a file. We use R to open a file just for reading. We use W to open a file just for writing, which will overwrite any contents that already exist in the file. If we don't want to overwrite an existing file, we use A to append all the information to the end of the file, keeping the contents in the file that were already there. R plus and W plus can be used to open a file for both reading and writing. A plus is used to open the file for reading and appending. We hope you now have a good understanding of the file system structure on a computer, as well as the basics of opening a file in Python. In our next video, we will go into more details on reading and writing files in Python. Thanks for tuning in, and I'll see you around campus.